Good afternoon, ladies and gentlemen. Today we are going to be looking at solving linear and absolute value inequalities. So the first thing we want to do is we want to talk about some of the graphs and different types of notations we have. So if you look at this graph real quick right here, you can see that from a previous math course, you've probably seen that as that's everything greater than or equal to 3. So what we call set notation is called squiggly bracket. And so you're going to say x with a bar like this, which means such that x is greater than or equal to 3. Now, in interval notation, you're going to use something with brackets or parentheses. So since it's inclusive, we're going to go 3, comma, all the way to infinity. And infinity can't be, you can't touch infinity, so you go with the parentheses. How about the next one, -6? That's got an open circle. In set notation, you're going to go x such that x is less than -6. In interval notation, that goes all the way to negative infinity, so it's a parentheses. And since it's a open circle, it's going to be -6 with the parentheses. This one's fun. This one's just all reals. And what does that look like in interval notation? Negative infinity to infinity with parentheses. This one is uses the or. This is a compound inequality, okay? So compound inequality. So basically what you would say, you use squiggly bracket, you could say x such that x is less than 1 or x is greater than 5. Now in set notation, in interval notation, it would look like this. Negative infinity, comma, 1. We use this funky looking U, which is union, and then 5 to infinity. That's set notation and interval notation. A couple more examples with those because I know that it's kind of weird. So let's look at the next one. This guy is again compound inequality. This is an or. So we use squiggly bracket x such that x is less than -7 or x is greater than or equal to 2. Nope, gotta bring that down a little bit. Sorry about that. And so in interval notation, this would look like negative infinity to -7 union bracket 2 comma infinity with the parentheses. This one is and, okay? This one is and. So this one you could say squiggly bracket x such that, and you write it like this. It's between -4 is less than x is less than 0. As a interval notation, you would just write it as -4, 0. This last one is also an and. So squiggly bracket x such that -1 is less than or equal to x is less than 8. In interval notation, it would be bracket -1, comma 8 with the parentheses. So that's probably pretty new. The rest of this stuff is going to be things that you've already seen. So if you look at this, guys, solving linear inequalities, remember if you multiply or divide by a negative, you just flip the inequality. That's it. So just walk this through. So this is -12x plus 6 minus 4x is less than -90. And then we got -16x plus 6 is less than -90, right? So then we subtract 6. So you get -16x is less than -96. And then we divide by 16. And when we divide by 16, I circle that. And the reason why I circle that is so I know I go x is greater than 6. So then I write it on a number line. That would look like this. Here is 6, open circle going that way. So as interval notation, open circle, comma, negative infinity or positive infinity. As set notation, it would be squiggly bracket x such that x is greater than 6. So that's pretty much what you do. Got another example for it. This one, we're going to combine our like terms. So you got negative 8x minus 2 is greater than or equal to negative 8x minus 2. And then if I add 2 to both sides, I get negative 8x is greater than or equal to negative 8x. Wait a minute. That is all reals. What's that look like? Negative infinity to infinity. And on the number line, it'd just be like this. That was a fun one. All right. Something that you probably have super limited experience on, and that would probably be the absolute value inequalities. So these, same rule, you isolate, you create the two cases, you solve both cases. But here's the crazy thing. If it's greater than or greater than or equal to, it's an or the union. If it's less than or equal to, it's an and or the intersection. So let's look at this one. All right, so it's already isolated. We're going to set up two cases. 5 minus 10a is greater than 15. And then you're going to do 5 minus 10a is less than negative 15. See how I flipped it? All right. And so then you just solve it. So we're going to subtract 5 here, subtract 5 here. Negative 10a is greater than positive 10. And then divide by negative 10. Circle that, divide by negative 10. A is less than negative 1. Here you subtract 5, negative 10a is less than negative 20. Divide by negative 10, divide by negative 10. Circle that. A is greater than 2. And this is an OR. So what does it look like? You're going to say negative infinity to negative 1 union 2 to infinity. And then on a number line, it looks like this. Here's negative 1, open circle, you're going that way. Here's positive 2, open circle, you're going that way. But we started this out, this is an OR because of from the jump right there, if that makes sense. We're going to have another couple of examples on that. So here's this one. So the first step you do on this one is you're going to, first off, you're going to isolate the variable. So we're going to add 4 to both sides. So now you got the absolute value, right, is less than or equal to 4. And then now you set up the two cases. X is minus 3 is less than or equal to 4. And since this guy goes here, it's an and, right? So, and x minus 3 is greater than or equal to negative 4. And then you just solve it. Add 3 here, add 3 here. X is less than or equal to 7. And at the same time, I add 3 here and add 3 here. X is greater than or equal to negative 1. What does this look like in interval? Well, you can write it like this. Negative 1 is less than or equal to x is less than or equal to 7. Because this, you see how the arrow's pointing to negative 1? I could write it like that. And that makes sense. Interval notation, it would be this. And on the number line, you got 1, 7, solid, solid. Draw a line in between them. So hopefully that's somewhat of a review. If not, it's okay. And then we have this one. So this one, same thing. You want to divide everything by 8. So then we get the absolute value of 3 minus 3x is greater than 15. Set up two problems. 3 minus 3x is greater than 15. And since it's greater than, that's going to be an OR. 3 minus 3x is less than negative 15. Subtract 3, negative 3x is greater than 12. Divide by negative 3, circle that because you're dividing by a negative. X is less than negative 4. Or subtract 3, Negative 3 is less than negative 18. Divide by negative 3, divide by negative 3. Circle that. X is greater than 6. So then this is going to look like, that's the OR, and then you got negative infinity, comma, negative 4, union, 6 to infinity. On a number line, looks something like this. Negative 4 with an open circle going that way, positive 6 with an open circle going that way. Sound good? Awesome. One more. We're going to do one more and we'll be good to go. So this one, first thing we want to do is times everything by 4. All right, and since it's less than or equal to, going back to our little chart, I believe that's an and, right? So then we set up 12 minus 4x is less than or equal to 8, and 12 minus 4x is greater than or equal to negative 8. And then you just solve it. Minus 12 minus 12. Negative 4x is less than or equal to negative 4. Divide by negative 4, divide by negative 4. Circle that. X is greater than or equal to 1. And subtract 12, negative 4x is greater than or equal to negative 20. Divide by negative 4, divide by negative 4. Circle that. X is less than or equal to 5. So what's it look like? Remember, this guy I could write it as 1 is less than or equal to x. So if I do that, I can bring this guy down right here. And then interval notation looks something like this. And on the number line, we got a 1 here, solid circle, and a 5 here, solid circle, shade in between. All right, so that should have been pretty much review, but if it wasn't, it is what it is. I look forward to seeing your class real soon, and may the force be with you.